Hello. In last video lecture, we had discussed uh, various CPU scheduling criteria. We have focused on what is processor utilization. Then we moved into throughput. So we had completed these two things. Now, today we are going to pick what is turnaround time. We had picked that processor utilization says that you should keep busy your CPU continuously. Throughput says that how many number of processes get completed per unit of time. So, what is turnaround time? Now, turnaround time says that process how much amount of time any process takes to complete its execution. Now, suppose there is one process P1. Now, P1 started its execution into the CPU and it executed for 30 unit of time. Now after 30 unit of time, suddenly due to certain interrupt, process was moved out from the CPU. Now if it is moved out from the CPU, then how much amount of time it took for moving again further in? And that is the major concern, that if process is moved out, uh, suppose due to as we had discussed that there are certain non-maskable interrupts. So due to non-maskable interrupts, I am assuming that my process get out for 10 unit of time. Now again it got execution, and after again 10 unit of time execution, it got terminated. So how much amount of time this process has spended from its creation to its completion? So that is 30 plus 10 plus 10, which is 50 unit of time. And that 50 unit of time is actually known as turnaround time. In short form, we will call it TAT. So if I divide this turnaround times, so it says that turnaround time turnaround time is actually a combination of burst time plus waiting time. Now what is this? Burst time. Burst time means time taken for execution in CPU. And waiting time, that process due to certain time it has waited outside. Now there is a possibility that process wants to execute for any IO. So due to performance of or due to performing functionality of IO, that process wants to go to outside CPU, or due to certain any non-maskable interrupt, it got out from the CPU. So for any reason, or time got completed. So for any reason, if process is going outside, then this will added into the waiting zone. So that is waiting time. So time taken for waiting plus time taken for execution. If I'll add these two, this becomes total time taken by process to complete its task. That is turnaround time. So I hope we have also cleared that what is waiting time. Waiting time, the process has waited for its chance for execution into the CPU. So that is waiting time. Now, apart from these two things, there is one more thing, and sometimes that becomes quite crucial criteria for selection of any algorithm. And that is the main thing that we focus on that particular thing. And that thing is our fifth one, that is what we can say response time. Now, can you differentiate between waiting time and response time? Because both looks quite similar. So, according to you, what is response time? Can you elaborate what is response time, or can you identify difference between these two things, waiting time and response time? So, let's pick response time is also some kind of waiting time, means it's a subset of waiting time. So, what is actually response time? Response time is, you can say, first waiting time. Now, what do you mean by first waiting time? First waiting time is that suppose process arrived into the ready state, process came here at 9 a.m. and it first got chance for execution into the CPU at 9:15 a.m. So what happened that 15 minutes process has waited into the ready state for getting its first chance of execution, and that is known as response time. Now, how it is different from waiting time and why we are saying that response time is subset of waiting time. So, let's take one example here. There is one process Px. It arrived, suppose, at 0th time, and what happened that 5 unit of time, I'm always saying unit of time. I'm not considering any specific unit of time like hour, minute, like this. I have used here clock time. Generally, I will not prefer this thing or minute or second or millisecond, because once we try to calculate things, it becomes quite complex, and a student tends to focus on these units instead of calculations. So most of the time I use the term unit of time, where you can assume any unit, and that is universal. So here we were discussing that this is one process Px at starting 5 unit of time that has waited. After that, it got selection for the execution, so it moved into the CPU. It executed for 10 minutes, so time becomes 5 plus 10, that is 15. Then, for performing certain IO, it moved out for 5 minutes, again waited, then again that got for execution into the CPU. and again executed for 10 minutes. Now, after that, it got terminated. So, the thing is that if I'll focus on this thing, that is, let's do the calculation here. What is for Px we were focusing? What is burst time? Burst time we said that is CPU time. How much amount of time that process has invested into the CPU? So it becomes 15 minus 5 plus 30 minus 20. And that total becomes, this is 10 plus this is also 10. So it becomes 20. Now, next one is waiting time. Waiting time says that at the start it waited for 5 minus 0, then it waited for 20 minus 15, so this becomes 5 plus this becomes 5, so it had waited for 10 minutes. So what is turnaround time? TAT is 30 unit of time. What is waiting time? Waiting time is 10 units. What is burst time? 20 units. So what is response time here? Response time means at first instance, how much amount of time this process has waited to get its first chance of execution. So that is my response time. Now let's pick that why response time is quite interesting criteria and which is used generally. Let's take one example, and I'm sure you have seen that thing. That suppose you are in queue. Uh, Suppose you want to do certain kind of shopping, and you move into any uh, big shopping complex. Now, there are two things, or there are two ways you can be engaged. The first one says that what you can do, you can form the queue and you will wait for your time for entering into the market and getting your things. So there is a possibility that you will wait for 1 hour. The second one says that what I can do, after 5 minutes you can enter into the market, but you can only shop for 5 minutes or 10 minutes. After that, you need to again wait. So, which thing generally we prefer? So, the answer is that normal tendency says that public will prefer where you have not waited for a longer stretch of time. That is general perception. And that's why response is required quite effectively. So, if any algorithm focuses on response time, that is quite useful and close to the real time environment. Now, let's take another example, and I'm sure you all will agree with that thing. In earlier, computer used to get boot up in 2 to 3 minutes. And if I'll go to more starting one operating system, so it generally took 3 to 5 minutes. Now, in nowadays, Suppose if any system will take 5 minutes, will you wait for 5 minutes? Not at all. Now, let's uh, have one trick into it. Right now, also, system generally takes 2 to 3 minutes. But what they actually do, just like Windows XP or any Windows, they try to showcase you certain logo or certain bar which is moving. Now, traditionally, there is no relation between that bar movement with the loading. It's totally different. It's just to engage you, to give you certain response so that you can see those things and you forget that loading is taking time. So that is the primary thing. Nowadays, Windows is working on uh, zero booting time. That if you will open the system, immediately it will prompt you your working environment. They are working on it. Right now, they have not achieved it so far. So that is the response that each and every one wants to get first interaction as early as possible. So that is the response time and its importance. So it is very important criteria once we focus on any specific CPU scheduling mechanism. So these are different criteria which are focused once we discuss different CPU scheduling algorithms, that okay, which scheduling algorithm is performing better. So the question arises that in which criteria you want to check that this particular algorithm is performing better. Is it response time? You want to check that out of these three algorithms, which algorithm is giving better response time, or which algorithm is giving better waiting time. Better waiting time means less waiting time, or which algorithm is providing better throughput. So on the basis of these different criteria, we select our CPU scheduling algorithm. So these are scheduling criteria. Now, in next lecture, we will focus that what are different scheduling algorithms. So we will discuss one by one each and every scheduling algorithm. So that's all for today. We have completed our scheduling criteria, performance criteria. Thank you.